Let's have our lecture video in integral calculus with the topic Integration Techniques, letter C, Integration by Trigonometric Substitution. The last video we have the algebraic substitution. Now this time we have the trigonometric substitution. In calculus, trigonometric substitution is a technique for evaluating integrals. Moreover, one may use the trigonometric identities to simplify certain integrals containing radical expressions. Now, when the integral has this a squared minus x squared, we will try x is equal to a sine theta. If the integral has a squared plus x squared, we will try x is equal to a tangent theta. And when the integral contains x squared minus a squared, we will try x is equal to a secant theta. Now, let's solve the following examples. Number 1. The integral of dx over a squared plus x squared raised to the power of 3 halves. Now, since we have here a squared, so we have a squared plus x squared. So from our note, that means we will try x is equal to a tangent theta. So we have here, try x is equal to a tangent theta. Now we call this substitution because we will replace all values of x with a tangent theta. Now, derivative of x, because we have dx here, that becomes a secant squared theta d theta. So that's the derivative of tangent theta. Then we will now substitute for the original equation. We have here integral of, for dx we have a secant squared theta d theta. Then we have here a squared plus x is a tangent theta squared raised to the power of 3 halves. Now we have here a secant squared theta d theta all over a squared plus a squared tangent squared theta, then all raised to the power of 3 halves. That's equal to say a secant squared theta d theta. Then we will bring out a squared. So what's left here is 1 plus tangent squared theta raised to 3 halves. So let's just continue that. So a secant squared theta d theta all over. So what is a squared raised to 3 halves? That is, cancel out 2. So what's left will be a raised to 3. Now how about this? This is already an Pythagorean identity. 1 plus tangent squared theta. That is, yes, that is secant square theta, then raised to 3 halves. Next, since we have here a over a raised to 3, so that becomes 1 over a squared. This. Then, what happens here? We have secant squared raised to 3 halves. So, we cancel 2. What's left will be, so secant theta d theta. What's left is secant raised to 3 theta. Then 1 over a squared. Cancel out. So we have there d theta all over secant theta. Now we know that 1 over secant is cosine theta, or that cosine theta is equal to 1 over secant theta. So this becomes 1 over a squared integral of cosine theta d theta. And what is integral of cosine theta? Is equal to 1 over a squared, that is sine theta plus c. 1 over a squared sine theta plus c. But this is not yet the answer. Remember that what we did here is we substituted the value of x as a tangent theta. So we will, so we can still use this space in the right side. But x is equal to a tangent theta. And in SOHCAHTOA, remember SOHCAHTOA, we are dealing with tangent. When we are dealing with tangent, that means tangent theta, O means opposite. So that is x. So looking at this part here, tangent theta is equal to x over a. Right? This is this part here. And in SOHCAHTOA, we have this as the opposite and then adjacent. So in the triangle, oops. So let's close the triangle, okay? So in the right triangle, if we have this as the theta, then dealing with tangent theta, the opposite is x, then the adjacent is a. So what is the value of the hypotenuse c? For the hypotenuse c, we have here c squared is equal to a squared plus x squared. C is equal to square root of a squared plus x squared. So here we have c is equal to square root of a squared plus x squared. Okay? Therefore, remember that the answer here is 1 over a squared sine theta. So we're dealing with sine. Therefore, sine theta is opposite over the hypotenuse. It's the SO. SO means sine theta is equal to opposite over hypotenuse. Therefore, from the triangle, we have sine theta, the opposite is x, and the hypotenuse is the c. Square root of a squared plus x squared. Now, having found the value for sine theta in terms of x, we will now do the final step, which is the substitution. Substitute here in the answer. We have there 1 over a squared. Sine theta is x over square root of a squared plus x squared, then plus c. Therefore, the final answer here is x over a squared square root of a squared plus x squared plus c. So this is the answer. So that's your substitution by integration by trigonometric substitution. Okay, that's for number 1. Let's go to number 2. Integral of square root of a squared minus x squared dx. C since we have here a squared minus x squared from our lecture, so a squared minus x squared, we will try x is equal to a sine theta. Okay, so try x is equal to a sine theta. Since we have dx here, let's find the value of dx. Derivative of x is equal to a. Derivative of sine is cosine theta. First substitution, substitute the values. So we have there integral of a squared minus the x is a sine theta squared. Then dx is a cosine theta d theta. Okay, so we can't use this space anymore later. So that is equal to integral of square root of, let's bring out a squared. That becomes 1 minus sine squared theta. Then we have here a cosine theta d theta. Square root of a squared, that is a. A times a here, that will be a squared. And square root of, how about this one? What is 1 minus sine squared theta? It's a Pythagorean identity wherein the answer is cosine squared theta. Then we have here cosine theta d theta. So that is equal to a squared. What is the square root of cosine squared theta? That is cosine theta. What is cosine theta multiplied with cosine theta? That is cosine squared theta d theta. Then equal to a squared. Now what happens here is we will be using the trigonometric transformation. So if we are dealing with an even exponent here, so in the previous video we have discussed already trigonometric transformation dealing with even exponent. That is, we multiplied with the half angle formula, 1/2 1 plus cosine 2 theta d theta. Okay, so if you're going to ask question, how did I do that? Then go watch the previous video on trigonometric transform. Then let's distribute. Using distributive property, we have here a squared over 2 integral of d theta plus a squared over 2 integral of cosine 2 theta d theta. Then let u is equal to 2 theta here, du is equal to 2 d theta. So we have here trigonometric integration here. So we have a squared over 2 integral of d theta plus a squared over 2. And then we have here 1/2. Why I'm going to put 1/2? Because we have here cosine 2 theta 2 d theta. That is to balance. Just what we are doing in the previous videos. So a squared over 2. This is, what is the integral of d theta? That is theta. Plus a squared over 4. Then what's the integral of cosine 2 theta? That is positive sine 2 theta plus C. Now that's not yet the final answer. Take note that we should have an answer in terms of x. What we have here is in theta. Okay. Sine 2 theta. So the angle here is 2 theta. But what we have here is sine theta. So what should we do in here? This is actually another identity, half angle. So we have here a squared over 2 theta plus a squared over 4. Sine 2 theta is actually 2 sine theta cosine theta plus c. So that is equal to a squared over 2 theta plus a squared over 2 sine theta cosine theta plus c. Finally, we are going to be consistent here. Sine theta and cosine theta. So we have here sine theta. Now from SOHCAHTOA, so it says here, but we used x is equal to a sine theta, and then we have here sine theta is equal to x over a. Now in this SOHCAHTOA, again, let's write here. So let's just put here for a guide. So for sine, we have opposite over hypotenuse, meaning x here is opposite, a here is the hypotenuse. Let's have the triangle. Right triangle, if this is the angle, theta, the opposite is x, hypotenuse is a. Therefore, C here, C adjacent will be, okay, so using Pythagorean identity, we have there A, or Pythagorean theorem, should I say. So A squared, the hypotenuse is equal to C squared plus x squared. What we're looking for is the value for C. So we have here C squared is equal to A squared minus x squared. C is equal to square root of A squared minus x squared. So square root of A squared minus x squared. Okay. Now take note that in this answer here, we have sine and cosine. So from SOHCAHTOA, we have for cosine, so we still have space. For cosine theta, ka here, cosine is equal to adjacent over hypotenuse. Adjacent is C, which is square root of A squared minus x squared all over hypotenuse A. So adjacent and hypotenuse. Then, so from the answer that will be substituted, we finally have sine theta. We have here the value for sine theta. We have the cosine theta. This is the value for cosine theta. How about the value for theta only? How about if we are dealing with theta only? Okay. So using sine theta is equal to x over a, we can have the value for theta by having the inverse of sine or the arc sine of x over a. Or if we're dealing with cosine theta, is equal to square root of a squared minus x squared all over a. Our theta becomes arc cosine of square root of a squared minus x squared all over a. So we can have two values for theta, the arc sine and the arc cosine. Substitute the values. Where's the answer again? So there is the answer. Substitute here. So we finally have here a squared over 2 theta. Our theta is arc sine of x over a plus a squared over 2 sine theta is x over a. Cosine theta is square root of a squared minus x squared over a. And don't forget plus c. Finally, we have a squared over 2 arc sine x over a plus, let's have a space here, plus, okay, so cancel out a squared. So what's left is x over 2 square root of a squared minus x squared plus c. So that's the final answer. A squared over 2 arc sine x over a plus x over 2 square root of a squared minus x squared plus c. Or, we're using arc cosine. Okay, or, so we have here a squared over 2. For theta, we will have arc cosine of square root of a squared minus x squared all over a plus a squared over 2 times x over a times square root of a squared minus x squared all over a plus c. So that is equal to a squared over 2 arc cosine of square root of a squared minus x squared all over a plus cancel a squared. So we have here x over 2 square root of a squared minus x squared plus c. So we have two possible answers. So that's for number 2. Okay, screenshot before we proceed to the last number. That's number 2. Last, we have number 3. Last example, number 3. The integral of d omega, so it's actually omega, but let's call it as w. So integral of dw all over w squared square root of w squared plus a squared. So take note that we can have other letters aside from x. We can have y, z, just consistent with this as constant. So this can also be other constant. Okay. So if we are dealing with w squared plus a squared, then what are we going to try? So w squared plus a squared, that is this one here, x squared plus a squared. So we're going to try again a tangent theta. So try w is equal to a tangent theta. So dw is equal to a secant squared theta theta. Therefore, we substitute. First substitution, that is integral of, for dw or d omega, we have a secant squared theta d theta all over, let's have w squared or omega squared, that will be a tangent theta squared square root of w or omega squared tangent theta squared plus a squared. Okay, that is equal to okay, so since this is a tangent theta squared, square of a is a squared. If a squared, and then we have a on the numerator, what we have here is 1 over a. And what's left in the numerator is secant squared theta d theta. All over, this becomes tangent squared theta square root of a squared tangent squared theta plus a squared. Then that is equal to 1 over a integral of secant squared theta d theta. Then you have here tangent squared theta square root of, so let's bring out a squared, so what's left here is tangent squared theta plus 1. Again, that is another Pythagorean identities. So another Pythagorean identity, tangent squared theta plus 1. Over a integral of secant squared theta d theta all over, that is tangent squared theta. So since we have there square root of a squared, that is a times a here becomes 1 over a squared. So I just brought there the a. Then here this becomes square root of secant squared theta. So 1 over a squared. Then what is the square root of secant squared theta? That is secant theta. Then what happens here is we cancel out 1 secant theta. So what's left in the numerator is secant theta d theta all over tangent squared theta. Then let's use cosine and sine here. For secant theta, again, secant theta is equivalent to 1 over cosine theta. For tangent square theta, we have there sine over cosine, but since tangent here is in the denominator, so we have here sine squared theta over cosine squared theta and d theta. Cancel out cosine, then let's put sine 2 theta, sine squared theta on the numerator, so 1 over a squared, so it becomes sine raised to the power of negative 2 theta, then cosine theta d theta. We can use power formula here. Let u is equal to sine theta, du is equal to positive cosine theta d theta. So that is equal to 1 over a squared sine negative 2 theta cosine theta d theta. So 1 over a squared. What happens here is we have the power formula. So sine theta raised to negative 2 plus 1. So we have negative 2 plus 1 plus c. Then, this is now equal to, so, sine theta raised to the power of negative 1. This is negative 1. So, we have here negative 1 over a squared sine theta plus c. That's not yet the final answer. So, let's use the space here. But, omega or W is equal to a tangent theta. And we have here tangent. So, in the SOHCAHTOA, we have TOA. So TOA. Tangent is equal, tangent theta is equal to W or omega over A, wherein tangent is TOA, so opposite. A here is the adjacent. So in the triangle, in the right triangle, this is theta, the opposite is W or omega, then adjacent is A, so what is C? Using the Pythagorean theorem, C, hypotenuse squared is equal to adjacent plus the opposite all squared. So C now is equal to square root of A squared plus W squared. So C is equal to square root of A squared plus W squared or omega squared. So, since the answer here is sine theta, and then we have here SOHCAHTOA, so meaning opposite over adjacent. So sine theta is opposite over the opposite over hypotenuse. Opposite over the hypotenuse. Square root of A squared plus W squared. This is opposite hypotenuse. Substitute now. Final substitution is equal to negative 1 all over A squared. Sine is W over square root of A squared plus W squared plus C. So the final answer now here is equal to negative square root of A squared minus W squared or plus W squared all over A squared W plus C. So that's the final answer. So that's for number 3. So screenshot. So that's all in this video.